All right, guys, final example. Today, we'll finish up this first set of notes. And in this table is what we're doing very useful for you to figure out the kind of things that we're going to be requiring. So you can always go back and relook at this if you're having some trouble, or ask me questions when we have a time for that back and forth in one of our live sessions. So let's first take a look at the information we have here. So first of all, what we're creating is we're creating one of these. So we're trying to create something that looks like that or something that looks like that. So that's the goal. So the goal is to create what we call is a nuclear or an atomic symbol. All right. Now, if you look at the first line, so you're given some information and we're looking for that missing piece. And so this is where you want to start right here, protons. So protons, you're going to look on the periodic table. You're going to find the atomic number 27. That's going to tell us which element we're going to be dealing with. So let's go to our periodic table and look for number 27. So we're going through the periodic table, and right there, right in the middle, number 27. See that top number is 27. That is cobalt. Okay, so CO, but capital C, little o. So we're going to go ahead and we're going to put that over in our first box here. And so I'm going to write a C. Oops, got to change this over. I'm going to write a C and a little o. So there's your cobalt. All right. So C, little o. Now, we need a top left number, and we need a bottom left number, and we need a possible charge. So the areas that we're trying to fill out are going to be these spots here. So we're trying to put something here, here, and maybe there. You may not have something in this spot here. It just sort of depends. And so might be a 0, just sort of depends. So I'm going to get rid of those, and then we're going to go ahead and figure this out. So the bottom left number is going to be that 27. So your protons are going to go in this spot here, bottom left. So we're going to put a 27 right there. So the bottom left gets the 27. Okay. Now, the next column we have is electrons, and then we have the neutrons on the right. So we're going to do the top right. So the top right next, which is going to be my charge because I've got my electrons there. So what I'm going to have you do is in this box over here, in this box right here, we're going to be putting our information. So right there, number of electrons. I'm going to have you, I had you do this before, but I'm going to have you guys write this out. So the way I'd figure this out is I take protons minus electrons. So we could just, write this up here. We could write protons minus electrons is going to give us equals charge. So protons minus electrons, that's going to equal the charge. Okay, so in this box, 27 protons, 24 electrons. So let's just write 27 minus 24, and then 27 minus 24 is going to equal a plus 3. So that's going to be a plus 3. So that's going to give us this value here, and I'm going to put this in the upper right. So cobalt plus 3. Okay, how do we get that top left number? The top left number is how much it weighs. So we're going to add our protons and our neutrons. So we're going to go 27 protons plus our 32 neutrons. Okay, so we are always going to do it this way. So when I tell you guys to write things in, I'm wanting you to do that so you guys understand, okay, this is how we're going to do this. All right, so we're going to write that in there, and then we're going to have a 59 when you add 32 and 27, so I probably should have put that in there. So that 59 is right there. And that's going to slide up here in that top left spot. Now, that might be kind of hard to read, but that's 59 on top, 27 on bottom, and then the +3. Okay, let's figure it out in a situation where we don't have the other parts. So we're just going to be looking over here at what did they give us. Okay, so what they gave us was the symbol. Now, the first thing you should look at is that you should notice that there is not a charge in this situation. So in this position, there's nothing there. That means this has a charge of 0. So if you don't see anything, that's a charge of 0. So our protons are going to be the bottom left number. So we're going to come in here and we're going to say, okay, got 35 right there. Oh, wrong pen. I'm going to try that again. So let's go to the highlighter. And then we'll go right here, that 35. Well, that's not highlighting either. So, okay, well, we'll just skip it. And we will just put the highlighter right there, 35. So 35 is going to be the number of protons because it's the bottom number. Now, you could double check it if you want. You could go to your periodic table. You could find bromine. And when you find bromine, when you look at bromine, you're going to see, oh, bromine has a 35 on top. So that does make sense. Remember, we're not going to use the 79.90. That's not going to be used. So 35 makes sense. Okay, electrons. All right, so we got to think about this. If there's no charge, then the protons and the electrons have to be the same, right? So if there's no charge, your protons and your electrons are going to have to be the same. And so since it says there's no charge, then there's going to have to be, go ahead and switch my pen back. It's going to have to be 35 electrons because they have to cancel out. So if you think of it like this, it would be the idea of 35 minus 35 equals that 0. Okay, so that can kind of help you out there. Neutrons, the neutrons, we've got 80 and 35. So the way you figure out the neutrons is you take the top number minus the bottom number. And so the neutrons are the difference because the bottom's the protons and the top is both of them combined. So we take 80 minus 35, and that's going to give us our neutrons. Okay, so 45 goes here, and then that's all the information on that one. Okay, this next one, very similar to the first one. So I would pause the video at this point and then try to solve it on your own and then come back and see how I did it. Okay, hopefully you paused it and you gave it an attempt. So I'm going to show you how I would do it. So first thing is I'd look up number 25 on my periodic table, and I would say to myself, okay, right there, 25 is manganese, Mn. So number 25 is manganese. And so then I would slide back over to my example, and I would have written in my 25. Sorry, my manganese, not my 25. So I'm going to go ahead and got my red pen. So I'm going to go ahead and put capital M, lowercase n. It's always a capital and a lowercase. Maybe not the best looking n. Maybe we'll try that again. Okay, that one's worse. Maybe we'll just redo the whole thing. So here we go. Oh, yeah, that one looks good. All right, so here we go. The bottom left number and the top left number, we did this before. So first thing we're going to do is this 25. It slides in right here. So the bottom number is always going to be the lower number. So 25 is on the bottom. All right, so now let's figure out what the charge is. The charge is the top right number. So look at the 18 there. So just like we did on the first one, I would have done 25 minus 18 equals, and that's going to be a positive 7. And so we can put a plus 7 or 7 plus, however you want to do that. That can go right there in that corner. Okay, now to figure out the neutrons, I would take and add up the protons and the neutrons because the top number is both of them. So I'm going to do the 25 plus 30, and that's going to give us our 55, and that's going to go right here in that top left number. So 55 over 25 mn plus 7. All right, pause it again, and you guys go ahead and try the next one, and then I'll show you how I did it. Okay, hopefully you guys have attempted that. So let's take a look. I'm going to go over to the highlighter again. And so we are the 16 right there. That's going to be my bottom number, which is my protons. So I'm going to go ahead over here, and I'm going to plug in a 16. I can double check that on the periodic table if I want by going and finding right there, there's sulfur 16. Don't have to do that, but that's something that you could do. Okay, number of electrons. All right, here's a trick. See, there's a -2 there. All right, so this is a trick. If you have the charge and the bottom number, do the opposite. So instead of 16 minus 2, this is a little trick. Do 16. I think I'm gonna use my green pen. So I've been using that for the math parts. Do the opposite, which is going to be 16 instead of -2. Do 16 plus 2. So we do the opposite, and 18 is how many electrons we would have. All right. So 16 minus 2, that's going to be 18. And so that is the actual answer, is 18. Now you can do it other ways. I just think that's a pretty easy way to do it. Just take the bottom number and the charge and do the opposite. So that's saying 16 minus 2. We went ahead and we did the opposite. We did the plus 2 instead. Okay, neutrons. We're going to just take top number minus bottom number. So 30. Whoops, that is a highlighter. There we go. Let's try that again. 32 minus 16 equals 16. Okay. All right. Take a look at this next one, 9, 10, and 11. So we would look up element number 9 on our periodic table. Element number 9 is right here. That is fluorine. So we're going to go with an F, and we are going to put a 9 here. We are going to then do a charge of 9 minus 10 equals -1. So you can just put a negative sign there because chemists don't write down ones. You could do a -1 if you want, but just 9F minus. And then the 11, we're going to take 9 plus 11 equals 20. And that's how I'm going to get that top number. And this last one here, carbon 6 over 14. So my protons is, again, my bottom number. So that's going to become a 6. Then my electrons, you can just do the same trick. It's just that you could do 6 plus or minus. It doesn't matter. 0 is going to equal 6. So it stays the same. My trick still works. And the last one, we're going to do 14 minus 6 equals 8. So that would be your answer.